two lectures, we have learned about the durability of concrete as well as the permeability of concrete and carbonation of concrete. During this presentation, we we are going to study about chloride attack on a concrete as well as the sulphate attack on a concrete. I am Professor Pratap N. Shinde, working as an assistant professor in Sanjeevani College of Engineering. So let's first move towards the chloride attack. So as we know that the durability is very important in order to keep the structure intact, or it should be work properly throughout its service life. So in order to keep structural integrity, so care must have to be taken for the durability point of view. So chloride attack is the one which also reduce the durability. So we must have to study chloride attacks. So chloride attack is important from the durability point of view. If you refer to some research papers, from that it is found that 40% of the structural failure is due to only corrosion of the reinforcement, and this corrosion of reinforcement is in some part it is possible that chloride attack reduce the strength of structure drastically due to the corrosion of reinforcement. So oxide protective layer can also be destroyed by the presence of chloride attack. The oxide protective layer which is present on the outer side of the reinforcement in a concrete, and that will be get destroyed due to the chloride attack. It is primary cause of corrosion of reinforcement, and we have already seen that 40% of structures are failure due to the chloride attack or the corrosion of reinforcement. So chloride enters into the concrete through the cement, aggregate, water, and sometimes from the admixtures. So care must have to be taken that while using the admixture, it should be chloride-free admixtures. Sometimes the chloride enters into the concrete by the diffusion of environment also. So what are the different forms of chloride? There are the two forms of chloride. One is the bound form, another one is the free form. So bound form is again classified into two forms. One is the chemical and another one is the chemical bound and another one is the physically bound. Chemically bound chloride incorporated into the concrete by the hydration of cement, and physical bound chloride absorbed on the surface of gel pores. Free chloride is available, which results in the corrosion of reinforcement. So let's move towards the next slide. So ways of chloride attack. So there are the different ways of chloride attacks. So first way, due to inside of the concrete, the chloride present inside itself into the concrete at the time of preparation. So it will also help, or it will also cause of the chloride attack. Second one, through increases of chloride from outside to inside of the concrete structure. So from the chloride which is present in the environment, it will penetrate into the concrete through the pores or cracks in presence of water. So this is also one of the reason of the way of chloride attack. The reason of chloride present in the concrete. So there are the different reasons. So out of that we have learned some more. Use of seawater for the mixing. At the time of mixing, if we use the seawater, so in seawater there is presence of chloride, so that will enter into the concrete. Use of calcium chloride as an additive to increases the setting time. When calcium chloride is incorporated into the concrete to increase the setting time, in that case also the chances of chloride attack is more. Aggregate contain chloride. So those aggregate we are going to be used for the manufacture of concrete, that must be washed before they are used as a ingredients of concrete. Sometimes aggregate itself are more chloride content, so care must have to be taken before using such type of aggregates, or sometimes aggregate must have to be tested before they have to be used in a concrete. So there are some sources from the external agencies also. Use of seawater for the mixing, use of salt to melt the ice. So this is generally from cold countries. So they have used salt on the pavement slab in order to melt the ice. So in that case, whatever the carbonates, what are the chlorides which is present into the salt, they are penetrate into the concrete through cracks, and it will create the chloride attacks. So it will not only hamper the pavement slab, but it also hampered the garages parking slab also, because of sometimes the chlorine waters which are adhere to the or stick to the wheels of that cars or the trucks or the vehicles, and when it will park into the parking yard, it will deteriorate, or it will deteriorate the slab, parking slab also. Third, presence of chloride in the substance placed for storage. So at the time when we are storing the particular substances, care must have to be taken that it should be a chloride free environment. So chloride free environment is very important for the storage of the ingredients of concrete. Let's see the preventive measures for chloride attack. So first preventive measure is proper cover to the reinforcement. So cover should be well maintained. So for whatever the IS requirement is given for the different exposure conditions, maybe the mild, maybe severe, maybe the extreme. So according to that, and maybe the for which component part we have to, for different component parts the cover should be different. So we must have to provide the proper cover to the reinforcement. Coating of rebar by epoxy. Before placing the concrete into the reinforcement, or we can say that before placing the reinforcement into the concrete, it must be a epoxy coated. Care must be taken that in order to decrease the permeability of the concrete. Values of chloride ion for the initiation of reinforcement corrosion. So these are some values. If the value is up to the 0.2% by weight of the cement, so we can say that there is no risk of chloride attack. If this value ranges from 0.2 to 0.4%, then we can say that there is a low risk of chloride attack. But if its value ranges from the 0.4 to 1%, there is moderate risk, and if it is more than 1%, then there is a high risk of chloride attack. Then let's move towards the sulphate attack. So sulphate attack is also very important while studying the durability point of view. So as we know that the durability is increases if we make that structure watertight. So making the structure watertight is very important for the durability point of view. Sulphate attack also leads to the corrosion of steel reinforcement. So the sulphate attacks leads to due to some local sources also. So local sources like sulphate in a soil, sulphate in a groundwater, and sometimes sulphate in a seawater also. So sulphate in a dry form cannot be hampered to the concrete, but When it comes in contact with the water, it will become dangerous for the concrete. So for sulphate attack, we can say that liquid medium is very important. So there are the different sources of sulphate attack. What are that sources? The external sources and the internal sources. External sources are the agricultural soil. Due to use of fertilizers into the agricultural soil, so it is sulphate content in that soil is increases. And if we construct the some structure into such type of soil, so definitely there is a chances of sulphate attack. So internal, maybe if you use the seawater for the preparation of concrete, so there may be chances of sulphate attack, that is comes under the internal sulphate. So there are the different types of sulphate content. In different types of sulphates are like calcium sulphate, magnesium sulphate, sodium sulphate, iron sulphate. So there are the different forms of sulphate which indirectly cause the sulphate attack. So let's see. So what will happen due to external sulphate attack? Sulphate ion from the external sulphate attack due to sulphate ion from the external source. Internal sulphate attack, what will delay in ignite formation. Due to internal sulphate attack, there is a delay in ignite formation. The characteristics whitish appearance is the indication of sulphate attack. If you find out that there is whiteness on the surface of the concrete, it indicates that there is a sulphate attack. Due to sulphate attack, there is an increase in volume of concrete or mortar. So it is formed due to the chemical reaction between product of hydration and solution containing the sulphate. This volume changes because of there is a reaction between the product of hydration and solution containing the sulphate. Due to sulphate attack, there is a gradual disintegration of concrete. Now, if you look at this reaction is the calcium hydroxide with the sodium sulphate in presence of water. What will happen? There is a formation of gypsum formation. And if the gypsum formation starts, what will happen? There is softening and loss of strength, as well as the expansion of the concrete will start. So as all of you know that gypsum is a soft in nature, and therefore there is starting of softening of concrete. Another, if the magnesium sulphate is there, so it will form the magnesium hydrates, also cause the gypsum formation and crucialite formation. Further reaction of gypsum with aluminates and its hydrate and monosulfate leads to formation of expansive tritignite. So the further reaction of gypsum with aluminates will be very dangerous, and it will form the expansive trignites. CH loss, that's calcium hydrate loss, creates loss in a pH. That's alkalinity of the structure, alkalinity of the concrete is reduces. As the alkalinity is reduces, the protective layer which is present, oxide layers which is present around the reinforcement will start reducing. Hence, the corrosion of reinforcement will be starting. Maximum deterioration occurs with magnesium sulphate. In later stage, conversion of calcium silicate hydrates to non-cementitious magnesium silicate hydrates leads to complete disintegration. So in that case, so calcium from the concrete, we can say that it will be disappearing and magnesium takes its place. So the main constituent parts of the cement will start the reducing, and it will overcome by the magnesium. Hence, the concrete will start disintegrate drastically. So there are some methods of controlling the sulphate attack. So what are that methods? use of sulphate resisting cement and the C3A content, that is calcium aluminate contents. So quality of concrete must be improved. So how to improve that? We must have to well designed concrete, well placed concrete, well compacted with a less water cement ratio. As less water cement ratio, its compressive strength increases, and we can say that durability is also increases because the concrete becomes inert or it is impermeable. Use of air entering agent up to 6% reduces the segregation. So only 6% by weight of cement we have to use as a air entering agent, which will improve the workability, also reduce the bleeding and generate the greater impermeability. Hence up to 6% air entering agents is permissible. Beyond that we don't have to use. Use of pozzolanic admixture which increases the impermeability. While casting the precast element, use of high pressure steam curing is very important. So while casting the railway sleepers, use of high pressure steam curing is important. Also use of high alumina cement is preferable. So these are the 2 points today we have learned. One is the sulphate attack and another one is the chloride attacks. So in Pune University, if you refer the last 4 to 5 question papers, there is always question, write a note on sulphate attack and write a note on chloride attack. So friends, today we will conclude this session. Thank you very much.